Hi, welcome to NewTech YouTube channel. In this video, we are going to study and solve example on transmission parameters of two-port networks. Let's start. Study some important terms. First term, one-port network. Statement, a network in which current enters through one terminal and leaves through another terminal. Refer the diagram of one-port network. Current IA entering into network and current IB leaving from network. Second term, two-port network. Statement, a pair of two-terminal network in which current enters through one terminal and leaves through another terminal of each port. See the diagram. Currents IA and IC entering into port 1 and 2 with currents IB and ID leaving from port 1 and 2 respectively. Up till now we have studied important terms in two-port networks. Let's study representation of transmission parameters. Voltage V2 and current I2 are independent variables. Then voltage V1 and current I1 are dependent variables. Now transmission parameters in equation form represented as voltage V1 is equal to transmission coefficient A into voltage V2 minus transmission coefficient B into current I2, which is given by equation 1, and current I1 is equal to transmission coefficient C into voltage V2 minus transmission coefficient D into current I2, which is given by equation 2. The transmission parameters represented in two-port networks with voltage V1 and current I1 as. Let's refer the diagram. A two-port network is given with voltage V1 and current I1 are inputs at port 1, and we are measuring voltage V2 and current I2 at port 2 respectively. Please note it. Remember the current directions at the time of analysis of given network or circuit. Let's study case 1 of transmission parameters. Now substitute current I2 is equal to 0 into equation 1 of transmission parameters. We get transmission parameter coefficient A is equal to V1 upon V2, where current I2 at port 2 is 0. Now refer the network diagram. Current I2 is equal to 0 means we are obtaining coefficient A at port 1 and 2 using voltage V1 and V2, and it is a dimensionless quantity. Now study case 2 of transmission parameters. Let's substitute current I2 is equal to 0 into equation 2 of ABCD parameters. We get transmission parameter coefficient C is equal to current I1 upon V2, where current I2 at port 2 is 0. Refer the two-port network diagram. Current I2 is equal to 0 means we are obtaining coefficient C at port 1 and 2 using current I1 and voltage V2. Let's study case 3 of transmission parameters. Now substitute voltage V2 is equal to 0 into equation 1 of ABCD parameters. We get transmission parameter coefficient B is equal to V1 upon minus I2, where voltage V2 at port 2 is 0. Now refer the network diagram. Voltage V2 is equal to 0 means port 2 is short circuited and we are obtaining coefficient B at port 1 and 2 using voltage V1 and current I2. Now study case 4 of transmission parameters. Let's substitute voltage V2 is equal to 0 into equation 2 of ABCD parameters. We get transmission parameter coefficient D is equal to current I1 upon minus current I2, where voltage V2 at port 2 is 0. Refer the two-port network diagram. Voltage V2 is equal to 0 means port 2 is short circuited and we are obtaining coefficient D at port 1 and 2 using current I1 and I2. It is a dimensionless quantity. The transmission parameters of two-port network in matrix notation form represented as matrix D is equal to matrix T into matrix N, where matrix D represented with voltage V1 and I1, matrix T represented with the coefficient A, B, C and D, and matrix N represented with voltage V2 and minus current I2. We just studied important cases of transmission parameters. Let's solve example on the same. Example statement. Find the ABCD parameters for the network shown. Let's see the given data. Resistance R1 is equal to 12 kilo ohm, resistance R2 is equal to 2 kilo ohm, and resistance R3 is equal to 4 kilo ohm, where voltage V1 and current I1 are dependent variables and voltage V2 and current I2 are independent variables with ports labeled as 1 and 2. Solution case 1. We are obtaining transmission parameter coefficient A is equal to voltage V1 upon V2 with current I2 at port 2 is 0, means obtaining voltages V1 and V2 using equivalent resistance. Now calculate total resistance formula. Total resistance is equal to R1 parallel to resistance R2 plus R3. Now substitute values of resistances. R1 is equal to 12 kilo ohm, R2 is equal to 2 kilo ohm, and resistance R3 is equal to 4 kilo ohm. After calculation, we get value of total resistance is equal to 4 kilo ohm. Then value of voltages V1 and V2 are calculated as voltage V1 is equal to current I1 into total resistance, which is equal to current I1 into 4 kilo ohm given by equation 1. Now refer the previously studied network diagram. Let's obtain current IA using current division rule. We get current IA is equal to resistance R1 divided by resistance R1 plus resistance R2 plus resistance R3 into current I1. Let's substitute resistance R1 is equal to 12 kilo ohm, R2 is equal to 2 kilo ohm, and resistance R3 is equal to 4 kilo ohm. After simplification, we get current IA is equal to 2I1 upon 3, which is given by equation 2. Now we know voltage V2 is equal to current IA into resistance R3, which is given by equation 3. Now using equation 2, equation 3 becomes voltage V2 is equal to 2I1 upon 3 into 4 kilo ohm, which is given by equation 4. Now calculate transmission coefficient A as coefficient A is equal to V1 upon V2, which is given by equation 5. Using equation 1 and equation 4, we get transmission parameter A as coefficient A is equal to current I1 into 4 kilo ohm divided by 2I1 upon 3 into 4 kilo ohm. After calculation, we get coefficient A is equal to 1.5, and which is a dimensionless quantity. Solution case 2. We are obtaining transmission parameter coefficient C is equal to current I1 upon voltage V2 with current I2 at port 2 is 0, means obtaining voltage V2 in terms of current I1. Now voltage V2 and coefficient C are calculated as refer the previously studied diagram of case 2. Current IA is equal to 2I1 upon 3 given by equation 6. We know voltage V2 is equal to current IA into resistance R3 given by equation 7. Let's use equation 6, then equation 7 becomes voltage V2 is equal to 2I1 upon 3 into 4 kilo ohm, which is given by equation 8. We know formula of coefficient C is equal to I1 upon V2, which is given by equation 9. Now substitute equation 8 into equation 9. We get coefficient C is equal to current I1 divided by 2I1 upon 3 into 4 kilo ohm. After calculation, we get coefficient C is equal to 0.375 millisiemens. Solution case 3. We are obtaining transmission parameter coefficient B is equal to V1 upon minus current I2 with voltage V2 at port 2 is 0, means obtaining voltage V1 and current I2 in terms of current I1 using equivalent resistance. Now calculate equivalent resistance and voltage V1 as equivalent resistance is equal to resistance R1 parallel to resistance R2, which is equal to R1 into R2 divided by R1 plus R2. Substitute resistance R1 is equal to 12 kilo ohm and resistance R2 is equal to 2 kilo ohm. After calculation, we get equivalent resistance is equal to 12 upon 7 kilo ohm. We know voltage V1 is equal to current I1 into equivalent resistance. We get voltage V1 is equal to current I1 into 12 by 7 kilo ohm, which is given by equation 10. Then current I2 and coefficient B calculated as. Please note current I2 is in opposite direction of current I1. That is why current I2 having negative sign. Let's see, using current division rule, we have minus current I2 is equal to resistance R1 upon resistance R1 plus R2 into current I1. Substitute values of resistances. R1 is equal to 12 kilo ohm and R2 is equal to 2 kilo ohm. We get minus current I2 is equal to 6I1 upon 7, which is given by equation 11. Now, we know the formula of coefficient B is equal to V1 upon minus current I2, which is given by equation 12. Let's substitute equation 10 and equation 11. Then equation 12 becomes coefficient B is equal to I1 into 12 by 7 kilo ohm divided by 6I1 upon 7. After calculation, we get coefficient B is equal to 2 kilo ohm. Solution case 4. We are obtaining transmission parameter coefficient D is equal to current I1 upon minus current I2 with voltage V2 at port 2 is 0, means simply we are finding current I2 in terms of current I1. Let's calculate value of coefficient D as using previously calculated value of current I2 in case 3 as minus current I2 is equal to 6I1 upon 7, which is represented by equation 13. We know the formula of coefficient D is equal to current I1 upon minus current I2 given by equation 14. Let's substitute equation 13 into equation 14. We have coefficient B is equal to current I1 divided by 6I1 upon 7. After calculation, we get value of coefficient B is equal to 1.166, which is a dimensionless quantity. Just to recap, in this video, we have studied transmission parameters with its equations and calculations of its coefficients using two-port network. Also, we have studied example on the same. Thanks for watching my YouTube channel. Thank you.